the amount of fossil fuel saved by the entire Texas nuclear fleet. Another anecdote is that it saved 5 times the fossil fuel that wind energy saved in 2007. Let's begin by defining what is CHP. Basically, CHP, or combined heat and power, is a type of distributed generation that is located in close proximity to the end user or the energy consumer. It could be a building, it could be a campus, or an industrial site. It provides at least a portion of the city's electrical load. It captures the thermal energy for use in cooling, dehumidification, domestic hot water, space heating, or process heat. Now, CHP is a primary power source in the sense that they are designed to be a primary source of energy for the facility. The grid and the existing boilers are more supplemental in nature, and the CHP equipment is basically capable of 24/7 duty cycles. A very common misconception is that CHP is the same as backup diesel gensets. But unfortunately, backup diesel gensets are much more common, and they're totally a different concept when you compare it with CHP. Typically, these gensets are designed to run for a couple of days. They do not capture waste heat and are highly inefficient, and they have a heavy and high emission signature. And in many cases, we have anecdotal evidence that at times of emergency, the backup generators did not start, or even if they started, they broke down. And very often, backup generators cannot power. Now, CHP is extremely diverse. It can use many fuels: natural gas, petroleum, industrial waste heat, landfill gas, industrial and municipal wastes, wood and agricultural waste, and other forms of biomass. In terms of applications, CHP works in many applications: industrial cogeneration and waste heat recovery, campus district energy systems, commercial building integrated systems, and residential systems which are served by micro CHP systems. Now, here is a list of buildings where CHP makes a lot of sense, and in the commercial sector. They include hotels, prisons, airports, hospitals, universities, data centers, grocery stores, wastewater treatment facilities, refrigerated warehouses, emergency management facilities, homeland security and sanctuary locations. Now, in the industrial sector, CHP has a huge application because of the very close match between your electric and thermal loads. Glass, cement, chemicals, incinerators, pulp and paper, manufacturing, primary metals, food processing, fabricated metals, rubber and plastics, petroleum refining, and wastewater treatment. So as you can see, CHP can take many fuels, and it's applicable across a variety of market segments in both the commercial and industrial sector. Now let's go into the basics of CHP. Basically, this is a schematic which talks in a very fundamental level as to how CHP works. In the most typical CHP application, you have fuel that is being input into a prime mover. Now, combustion of the fuel takes place, and typically you have moving parts that produce work and generate, and is connected to an electricity generator, and you get electricity. Now, as a byproduct of combustion, you have exhaust gases, which are then led to a heat recovery steam generator, and the waste heat that is captured from those hot exhaust gases can produce domestic hot water, steam, chill water, can serve your space heating needs, and also be used in dehumidification. Now, let's begin to examine and break down what the different types of prime movers exist and how the waste heat can be actually captured in your particular facility. Basically, you have 4 types of prime movers. You have reciprocating engines, gas turbines, microturbines, and fuel cells. Now, each has its own merits and demerits and its application. Basically, your selection criteria of your prime mover will depend on electric load, the thermal load and application, your capital costs, and permitting in some situations. Now let's examine some key features of reciprocating engines. It's basically available in the 5 kilowatt to 10 megawatt range. There's a huge range in which reciprocating engines are available. If we were to look at it, basically engines have been around a long time. It's there in trucks, cars, mining equipment, drilling equipment, and also has been used in power generation. In a CHP application, engines have excellent part load operation, and the waste heat can be recovered from the engine exhaust or the engine jacket coolant. Engines have a very low first cost and a fast startup times. And the emission signature of engines has improved significantly in the past decade with the advent of lean burn engines and selective catalytic reduction or SCR. Of mention over here is the ARES program, which is actually a U.S. Department of Energy's research and development program. Primarily, the goals is to develop an advanced reciprocating engine systems that can lead to huge fuel savings and environmental benefits. There is a lot of cooperation between leading manufacturers and the national labs, and the program is ongoing. The basic goals of the program is to develop efficient state-of-the-art engines with the electric efficiency of almost 50%. Also, research is going into better combustion and lower emissions of engines. The third and important goal is to make these engines at affordable costs, not only first costs, but also maintenance costs. Here is a look at, to see how an engine actually looks like. This is how a reciprocating engine looks like. And these are the manufacturers. You have Caterpillar, you have Jenbacher, you have Cummins, and you have Dresser-Waukesha. There are several other engine manufacturers, and this is just for illustration purposes.